Hi, everybody. Today, I have the great pleasure of talking to Kevin Holmes of the Argonne Leadership Computing Facility. And so I'd like to introduce Kevin first, and also ask Kevin to introduce yourself and say a little bit about what you do and the organization you work with.
Hi, thanks, Michael. Thanks for having me on. As you said, my name is Kevin Harms. I work at the Argonne Leadership Computing Facility. At the ALCF, I'm a performance engineering team lead. And so the performance engineering group focuses on programming models, system software, and optimizing application codes for the machines that we have.
All right, that's great. Thank you. So today's talk will mostly cover how Argonne and the ALCF has been working with open standards and the experiences that they have. So can you share your experience with open standard software for HPC a little bit?
Sure. I've been in HPC more than 10 years now. And when I started, we had codes that were MPI and OpenMP using C and Fortran. And so that's evolved over time to where we presently are, where we have significantly more C++, but we still have C and Fortran. And along with OpenMP and MPI, we now have some other programming models, one of those being SYCL. And so that's kind of our kind of current experience.
I'm glad you mentioned SYCL, and I guess by inference, one API. Something to ask about, this is partly because Argonne and ALCF has decided to select SYCL as part of one API as one of their programming models. So when did you guys decide to go towards SYCL and one API, and what was your motivation?
Well, when we started on the road to acquiring this new machine that's going to be accelerator based with GPUs, we started looking at different programming models that were available. And there's always a strong desire to have something has potentially open source implementation, but also open standards. So, and that allows us to influence the standard in some way to benefit our users. And of course, at the time, OpenMP was developing some of their target offload, but that was still a less mature at the time we started this process. And we were looking for something that's been a little bit more mature, and SYCL has been around for quite some time and looked like an ideal target since it had multiple implementations and it had an open standard body that was behind it. And so those kind of fit our ideal points.
That's good. As you know, I used to be the CEO of OpenMP, so I was involved with some of the work there. And it's interesting that you point out that despite that, you were still wanting to go towards SYCL because of the C++, I guess, the C++ implications and the workload increase in that area. Yeah.
Yep.
How would you estimate the increase in workload has been from Fortran to C to C++ over the years? Have you noticed any shift in that area?
It's definitely so obviously there's many legacy codes in HPC that have been 10, 20, 30 years. And so you get, for example, an old Fortran code, it just keeps going, right? People just keep augmenting the Fortran. Recently, with the shift of adding these new heterogeneous architectures, it sort of forced people to think about, okay, I need to make more significant changes. I can't just add something new to my legacy code. You want to do something different. And so if I'm going to do something different, I have the choice to do something a little bit larger. And so we see a number of teams choosing to use C++ as their desired vehicle. And so having something that works in the C++ realm became significantly more important. We still, of course, have interest in the older codes, but there's just a huge influx of people doing rewrites now, choosing a modern language.
Right. So I remember back in my days when I worked on a compiler, which was both Fortran, C, and C++. It was increasingly difficult hiring Fortran programmers.
Yes.
At the beginning there. So you guys probably operate some of the biggest facility, maybe even in the US, maybe even the world. So would you be able to give us a thumbnail sketch of your exascale systems, what they would look like, how many labs involved, how many data scientists and developers, and specific, and then also what scientific segments you might serve?
Sure. I'll give you my best attempt. I don't know all of what's going on, but in our kind of area of the world in high performance computing, we have kind of right now there's two open science labs. So Argonne National Lab and Oak Ridge National Lab. They're both planning on deploying exascale machines. And there's also another lab, Lawrence Livermore National Lab, who is part of the NNSA, and they work on national security type workloads. They'll also be deploying an exascale machine. We work with both of those other labs, but we're most aligned with Oak Ridge because we both do open science. As far as developers and people working on exascale, that's a hard thing to answer, but I can give something. At ALCF, we probably have tens of people, right? We're a small division. At Argonne, there might be hundreds. And then in the wider, let's say HPC ecosystem that's around your classical basic sciences and engineering, there could be thousands of people working on applications.
Wow, that's a large number of people. So what scientific segments do you serve?
Yes. So at ALCF, we have this competitive allocation program. So we provide time to people who run on our systems for free. But in order to get that time, you submit a proposal requesting the time, describing your science. That's reviewed by a science panel. It's composed of, it's outside of the ALCF. There's many experts in the area to review these. And then based on the reviews, the allocations are given out and selected. And so that means we can potentially have any science area working on our system. But there are, of course, traditional disciplines that we see a lot of, and that's like your high energy physics, your chemistry with materials or electronic structure. In biology, you have molecular dynamics, and then in engineering, you have the computational fluid dynamics. Obviously, basically things that you have trouble to do with an experiment and you need to use simulation, those are the type of areas that we typically see.
Right. So simulation is a big part of your work. Do you do anything with machine learning and data science now as well?
So in the last few years, we've been adopting significantly number of people looking to do sort of the AI machine learning to augment their existing simulation codes in various ways. And so that's become a significant driver for our next generation machines, as there's a lot of interest in these new type of workflows. And so those will become important at ALCF.
Right. So we mentioned a little bit about exascale, and obviously this is very exciting news. The world is trying to break into exascale computing, and there's a potential that your machine, Aurora, could be the first one, but there might be other ones. It's quite a big competition, as I understand it.
Yes.
Could you outline a little bit about your current position and strategy? I know that there might be some secrets, so say what you feel safe to talk about in terms of those efforts.
Yeah, we have our Aurora is the name of our exascale machine. It's currently, we believe, will be deployed in 2022. It's a machine that uses GPU accelerators. Our prime contractor is Intel, so it'll be an Intel-based machine. There's some information available on the web that's public, and Intel, of course, has many disclosures related to the technologies that will be relevant to ALCF, as talking about their Ponte Vecchio GPU and their Sapphire Rapids CPU.
Right. And specifically about Intel here, because Intel is championing one API, and SYCL is one of the standard programming models within one API. This is probably one of the things that you'll be using.
Yes, for sure. Obviously, we don't have any, we don't require people to use one programming model or another, but the ALCF has spent a lot of time looking at different programming models, and SYCL has become one of what we believe will be a preferred programming model. And of course, we'll support others, but we'll help people convert codes to use SYCL and to help them optimize codes that do use SYCL.
Yeah, I dare
as well
say
as
that.
their wider one API.
Right. I dare say that I know that you guys put probably more effort than anyone else that I know across industry, academia, at evaluating programming models, because that is
Yes.
so important to you guys. So I mean, I trust you guys in terms of what you're doing. But so on the programming models, my favorite subject, I've been a kind of a programming model scientist for 20, 25 years now. Why SYCL? I think this is a question that other people has asked. I think I know the answer, but I'd like to find out where you guys came from, because as the CEO of OpenMP in the early 2010s, I know that OpenMP has been the favorite programming language for 25 years and probably will be for many years to come. But now, why move to SYCL? Why move to another programming language?
Yeah, I mean, we'll still continue to support OpenMP, and I think it'll still be an important part of our workloads. But we also wanted to have like an accelerator focused programming model, and to allow people to extract the highest performance. We also believe it might be a little bit more, let's say, nimble than OpenMP, and so provide people an opportunity to explore, because GPUs have been around for a while, but now we have a lot of codes moving into GPU enablement or accelerator enablement, as well as probably future accelerators. And I think having SYCL as a programming model available for our applications developers is going to be important, because I think there's going to be a lot of architectural changes over the next 10 years.
Right.
We're also interested because it had an open standard. HPC is a niche type market, and this gives us an opportunity to take all of our users' desires and try to influence a standard, bring things into the standard that we believe will be good additions, not just to HPC, but to the wider programming populace as machines evolve, because we tend to be on the leading edge. And so we think stuff that we would like to do is going to eventually trickle down to the wider scale programming, and we just want to be at the forefront of that.
Oh, wow, that's great. You mentioned some great points about being on the bleeding edge, but you also want to serve the broader community, even beyond HPC. So that the stuff that you work on can trickle to the wider groups of people.
Yes,
yeah, go ahead. Yeah,
it's always important for us. We don't want to be on an island. Although we do like to be on the leading edge, we don't like to think of ourselves as doing something one-off or somehow that will be different. We want things we do to be applicable widely, and that makes it easier for users to come into the system. And so any kind of, in case in point, SYCL programming model that you can use on a laptop is ideal to bring people into a extremely large computer.
Yeah, that is so important. I'm going to reiterate. You don't want to be on an island, and you don't want to do things that is one-off, because I came through the ages where it was you heard of the term blue whale, because I work for a company that supplied you guys with blue whales. So my experience has been that your hardware might last 5, 10, 15 years before some replacement program comes in. And then software needs to last, your workload needs to last well beyond that. So is that the reason why you guys look towards open standards like SYCL or other ones like ISO C++? Or any ISO standardized language to support that drive? Does it drive you crazy having hardware replaced so frequently?
Yeah, exactly. We do like to update our machines, and we like a 5 to 7 year service cycle. Usually at that point, like the power to performance ratio is shifted enough that it warrants bringing in a new machine.
That's why. Okay.
But exactly to your point, people don't want to rewrite their software every 5 to 7 years. They like it to run for 30. And so having something is this an open standard that, we never know what our next machine might be from which vendor or which type of components it might have that will evolve over the next 5 to 7 years. And so we need something that can be adaptable and that any newcomers can come and say, okay, well, there's an open standard, we can implement this and provide you a potential resource for your center. And so, yeah, those elements are critical to the longevity of software.
Right. I think it's especially speaks to the point that you said that you never know when your next machine will be. In fact, during my 10, 15, 20 years of tenure in the high performance computing, supplying from a vendor side, I've seen you guys rotate from IBM, Intel, Cray. You seem to I don't know if it's deliberate, but it almost seems like you're deliberately rotating from machine. That's not the case, right? It just feels like one after 5 or 6 years, you go to another vendor and then you go to another vendor.
Yeah, we have a competitive bid process.
Right.
So we don't particularly set out choosing a machine, but we of course create the requirements for it. But we may end up with a different vendor. And so we like to establish partnerships with all vendors and keep those going through the duration of our center's lifetime. So, and having something that we can work with all vendors on. So if we have an open standard, we can go from one vendor to the other and not just yes, our users are insulated, but also we can have a working relationship, multiple vendors at the same time, working toward a common goal of making code run better on whichever platform we have.
And that's the case today. In fact, you're now basically working with almost all vendors simultaneously, sourcing machines that are Intel-based, AMD-based, maybe in future ARM-based, some with NVIDIA, some with Cray, all packaged by Cray, HPE now. So it is basically a multi-company effort now, right?
Yes, it's a complex environment.
Yeah. Don't envy you guys. So I do understand that A&L is not a traditional for-profit organization. In fact, I think you guys are much more closely aligned with the University of Chicago. Are you not?
Correct.
Yeah. So what were the metrics you guys might have used to measure success? I would say, talk about that in terms of developer efficiency, performance, code, reuse, refactoring, the ability to select algorithms early in the development phase for your target, things like that.
Yeah, it's hard to pinpoint a hard metric. We do have metrics for success, which there's this exascale computing program that has many projects underneath it each with potentially multiple codes. And so getting all those running on Aurora, if we do that successfully, that'll be our metric for success. But in order to enable that, going to the things that you were asking about, it's hard to define those specifically because we don't work as closely with the team, so directly measuring their throughput. But what we do is go in and evaluate programming models and look at, okay, how hard does it look like to adapt some CPU only code to now an accelerator based code, and what will it take in this programming model to do that? So we do look at things like developer efficiency, like how difficult will this to be, and then definitely performance, like how much performance will you get out of doing this transformation in, let's say, the simplest possible way. Like I'm sure every programming model can get the highest possible performance from any particular piece of hardware if you put in enough work. But we want to know with, some standard basic level of effort, can you get 80% of the performance? And that type of thing is a key metric. Like how quickly can we adapt a code to run on this system and get something reasonable performance, which like 70 or 80% of what an optimized code might get.
Right. That's good. That's a good point. In effect, you're kind of trying to reach a peak pinnacle where the amount of effort and the performance you can get is somewhere around 80%, and you can get maybe 80% of the performance, but 80% effort, not necessarily 100% of anything, because that's just that's almost impossible when you have so much things, so much work to do. You also have usually a suite of test programs. I remember seeing them when I was doing the Sequoia acquisitions.
Yes.
Yeah.
We always start with some like benchmarks. They can be full applications or mini applications or benchmarks, and we use those to evaluate the performance of the machine. And then vendors may have the opportunity to convert those to some other programming language or make some enhancements to them. And then we can look at those and be like, okay, you took this and then you converted to this, and yes, you get this performance, but this code maybe is not understandable by anyone who originally wrote this code. Or, hey, look, I understand, here's my algorithm in this code and I can find it over here and it makes sense to me. So yes, we do those evaluations as well.
Yeah, we always have to remember that the computer programming model is there to serve the needs of the user or the writer, and in this case, a scientific result. So they are not necessarily computer scientists in themselves.
Yes,
experts as physicists or astrophysicists or nuclear chemists.
Domain experts often aren't computer programming experts.
Exactly. So we need this programmer efficiency, ease of bugging, ease, understandability and things like that. So but in that direction, I understand that since we're moving toward heterogeneous computing with many kinds of offload, data has always been an issue. Every programming language is on the OpenMP language, about 60% of the instruction for the offload is data movement.
Yes.
The rest is just offload and specific things for NVIDIA, if I remember correctly. Would you like to say something about how important that is in terms of controlling data? And there are many specifics about controlling data that you might want to tell us about.
Sure, yeah. So I think our first goal, similar to our last discussion, like sensible defaults, of course, is what we desire. Make someone who's a scientific domain expert who spent their career learning about science, not a lot about programming, be able to do some efficient work with the least amount of effort. But at the same time, we desire to, there are codes that they are looking to get optimal performance, and having controls for those type of things like affinity or data movement is critical to achieving optimal performance. And if you don't have those type of controls, it becomes very difficult to achieve that. And so for the performance engineer, those are some of the most important elements in the programming language.
So so the answer is because of the performance. You need that data control to reach the kind of peak performance that you're looking for. And so some of the languages selecting, it's not just SQL. DOE also has languages like Raja and Cocos, and they specifically are able to control data layouts and things and locality. And
yes.
things like that, right. All right. That's fantastic. So we talked about heterogeneous dispatch. This is obviously, for a while there, we weren't sure if that was going to be just a flash in the pan, but now it looks like it's not. Like for 10, 15 years, I was wondering, is this just is it going to change something else 5 years later? Well, it's been 10 years and it hasn't changed. So the future seems to be firmly in the idea of heterogeneous distributed dispatch computing. And the SQL, of course, being modern C++ aligned, that's another side I wanted to explore with you, is why do you think C++ serves this particularly well for heterogeneous dispatch? Because C++ itself, the ISO C++ language, so does not have any recognition of GPU or even anything else other than an abstract machine on a CPU. So why C++?
Well,
what's your experience with that? Yeah.
I would say, first and foremost, users want to use a language that gives them a lot of things for free, and C++ does that. And some of the power of templating and those various aspects of the language will let code transformations happen that can be useful for this offload dispatch type of environment. And so I think that's one of the driving factors is the ability to use some of the language features to help enable the type of environment we have.
Right, right. So you're talking about the fact that C++ can do polymorphisms for templates, inlining, and parameterizing the code. That's yes. Pretty important. Yeah, and that is something that is was designed into C++ by Biana early, right from the beginning, and that's we're lucky that it actually is working out. So I think one of the things that I would like to learn is more about ALCF, Argonne Leadership Computing Facility. Does the name encompass a lot of facilities and machines, and are people able to send jobs to all the different machines, even though they might be from different vendors?
Yeah, we have, like I said, our largest machines have major allocations program, and you get time on those. And then we have some smaller machines for analytics and visualization. And those, if you have allocations on the main machine, you can get allocations on these other machines. And you might use those for specific parts of your workload. And you might choose to run some of your code there for a lot of times if you need to do preconditioning or some other type of thing where you're not going to be running at full scale, but you'd like to run on the system, you might, but in order to do that, you need to do some pre-steps, like you might do those on a smaller machine that we have.
So this has always been interesting to me, the fact that people can send jobs to different machines and they might be from different vendors. So this is another reason to support the open standards, right? So that you can have minimal change to your code when you move from, say, an Intel machine to an AMD machine, or I think you still have a lot of PowerPC machines.
Yeah, exactly. People just want to, when they bring their code on, they just want to recompile it. That's the only thing that they feel they should need to do. So yeah, of course, although maybe most of the effort, like in example, when we have Aurora, most of the effort of code development will go toward Aurora, but some parts of those code, they might want to run on another machine that we have for those various reasons. And so, yes, they expect, the code should just be recompilable and then run on that new system, regardless of who the vendor is. They don't even know. They just like, oh, I want to use this machine. I just need to recompile.
All right. Are there other leadership computing facilities other than ALCF?
Yeah, Oak Ridge National Lab is our kind of a sister lab to us. They have a similar mission, and they often run a completely different architecture than we do, but they have the same goals as large scale computing, serving people who need extreme number of cycles to run their science. And so large compute teams will often have allocations on multiple of these sites. And so, of course, again, they'll expect they can run their code at both sites with minimal work. And so we've been working to make sure SYCL is enabled on both Aurora and Frontier.
Excellent. So what has been your experience now with One API? Does it help further your goals of exascale computing? So it's been about probably a year, 2 years you guys have been working with it. This would be great to learn something from that experience.
Yeah, I think it's great that there's a wider ecosystem. Like you can have a programming model and that gets you part of the way, but in HPC, there's a very large reliance on math libraries and other support libraries. And if you don't have those in some portable manner, then you're kind of stuck again. And so the One API initiative to have sort of a standardized interface for not just in the programming language, but to carry that through into math libraries and other support libraries is going to be important. So I think that is still going to be an ongoing development and will take time to fully resolve, but I think that's a great step in the right direction.
That's great. With One API, it does have a lot of library components as well as language components, as well as other tools. So it's a very complete facility. Um, so what kind of workload does your organization plan to use with SQL and One API?
Well, like I said, we probably right now within the ALCF, we have people working on with several teams that might compose like a total of like 30 or 40 codes. So we may not be working directly on all those codes, but we're working with teams that work on those codes. And for each of those codes, they make their own decisions about what programming models that they choose. But there's some of those teams who will be using SQL. And for those teams, they've been working on adopting the One API work. And we'll hopefully be able to evaluate how that runs on both Aurora and Frontier.
Okay.
As well as other platforms such as at NERSC, which is another major compute center for scientists.
So we talked a little bit about this, the main pillars of focus of science problems of DOE. And as I understand it, you have work with simulations, work with data, and work with machine learning. So I think that's a pretty big, important area. Do you expect the focus on AI, ML, data science to increase over the years? And if so, what languages do you think you might adapt for AI and machine learning workloads?
Yeah, I do. I, as well as other people in our organization, believe that AI and ML workloads and data-centric workloads will continue to expand and be important components of our center. And so that's an ongoing mission to understand those. And right now in the AI ML area, it's very, as they say, framework focused. So they have these frameworks which go beyond just a programming language, but also are components to describe the way the entire program works together. And so these frameworks are often written in Python today. And so
Right.
supporting those frameworks is important for us today. They're great for the, let's say, the application user, because you have this very simplified workflow that you can put together and describe discretely. But when you want to run it on a machine to get performance out of it, you don't modify the user's code, right? You need to now go inside the framework and optimize that. And so one of our challenges going forward will be working on frameworks and making sure those the insides of the frameworks can be optimized for our HPC platforms in the future.
Right.
And so that's going to be, I think, a big hurdle going forward.
So as you know, Chronos languages do have a big focus on machine learning. So SQL is one of them. We've used it to convert TensorFlow from CUDA to using SQL. OpenCL, OpenVX, NNEF, and Vulkan to some degree. Do you guys have any interest in using some of these languages?
Yeah, I think so. We'll stick with like I think the major languages. The AI ML area is fast evolving. Like by the time you understand something, it's changed. I think so. We're just going to be tracking what happens there and trying to adapt with it and seeing where things fall out over time. Because I have a feeling there's going to be a lot of evolution over the next 5 years in that area, as there were in the past 5 years.
Yeah, that's wise, because it is still a fast changing area. And I'm assuming you guys are also developing some hardware in that direction or working with somebody in that direction.
Yeah, we have sort of as a tangent to the LCF, another I guess it's not another facility, but another part of where we have a bunch of AI test beds. So these are small units that we use for testing. We have other users within Argonne testing them and evaluating them. They're all various forms of different hardware that, generally work with one of the major frameworks. And that's kind of where we're starting. So I think that's going to continue that evaluation of these various different AI hardware.
So I'm
systems.
really interested to hear, but you may not be able to say. Can you say what that framework is? Is it TensorFlow or Py?
I think, TensorFlow is the most commonly used one, but PyTorch is also used. And so I think at least currently a lot of vendors will pick one or the other. They might support both if they've been spent more time working on. There also might be some other frameworks that I'm not aware of, but these are those are the two main ones. And if they support one of those, then we can usually start working with them.
What understood? Yeah, yeah. It would be great if you guys also take a look at what SYCL has done with TensorFlow. I think that would be good. I'm going to look at one more question and talk about a little more about open standards versus proprietary efforts. I know that through the years, you guys have always been supportive of open standards. Can you name some of the open standards that you're supporting currently?
Oh, well, as I said before, the oldest and probably the largest, or the one that's been around the longest, is MPI. We've also been involved in OpenMP. We haven't as done much as ALCF specifically. The wider HPC complex, of course, has been involved in languages, but the ISO-C, ISO-Fortran, ISO-C++, we haven't been as involved in, although we follow closely. Although today we are more directly involved in ISO-C++ now, and then getting involved in SYCL. Those are the open standards that come to my mind.
Right. I have seen an explosion of attendance by national lab people at the ISO C++ meetings in the last 5-10 years. And of course, recently in SYCL as well, too. You guys have people directly on the SYCL committee giving your feedback and the kind of things that you were interested in enhancing SYCL for. So that's fantastic. And so is that the reason why there are a lot of great proprietary languages? Is that the reason why, even though there are great proprietary languages out there, you try to stay away from them or not use them? But you still use them in private testing. Is that right?
I mean, we use them, and if users come and want to use a vendor-specific programming model, that's their choice, and we don't restrict that, and we'll help them wherever we can. But as we discussed earlier, we like to be vendor neutral. We want to work with all vendors because our next machine could be from any vendor, and so we don't want to go down a road where we've made many codes that are now tied to a particular architecture, and then those codes either can no longer run or take a large effort to transfer to a new architecture. And so from our center's point of view, we're heavily involved in open standards because that's what we want to see as the primary model that people choose for their application, so that they're runnable at more than just one center or one architecture. Right.
That makes a lot of sense. I remember RFPs that I had to sign. There was basically a list of standards that you had to conform to: C++, Fortran, and to what level, to what degree, OpenMP, to what version, and basically it just went straight down. And we needed to check mark every one of those, and we had to pass the check mark. You guys actually check our answers.
Yep.
It's the trust, but you verify what we're saying.
Yes. Yeah. Evaluation is an important part of the role of people in ALCF.
Right. I think it's great. We've always had a pleasure working with you guys on this, because it really furthers the whole progress of the human endeavor. It's the science side as well as the programming language side. You guys actually do make the programming languages better, and the fact that you say you're a small part of the pond, but you want to make sure that it also benefits the larger part. People actually are usually surprised at how, that HPC is a small part of the pond. It just speaks to the fact that even though you guys control hundreds of millions of dollars of machines and acquisitions, there's a far bigger part out there that is doing, consumer computing, games computing, banking. They're well into the billions and trillions of dollars.
Yeah.
It's just that each of your contract is big in themselves. But there might only be 3 or 4 of them at $600 million.
Yeah,
Where there's
exactly.
hundreds of millions of contracts at like a couple of $100,000 in consumer computing, and that's the big difference.
Yeah, and I would say, like, so going back to our topic, those are some of the underlying reasons for choosing, let's say, open standards, because sometimes a vendor specific standard or model, they might say, hey, you guys, like, yeah, you guys are important, but like we have all these other people. And so we're not sure the things you're asking for, we don't know about. That sounds maybe something like we don't need. So, because our market isn't asking for that. And so, we'll often try to be like, well, they'll be asking for that in 5 years. So we could start now. And when you have an open standard, that discussion is a little bit easier because one, you might have a vote, and two, you can help actually contribute to it directly. So you can say, well, here's an example. And, I think, large machines with like many accelerators on a node and things like that are probably less common in the wider market, but an everyday occurrence for new large HPC centers. So developing, like extending the standards to now support these more complex architectures is something that we want to be at the forefront of, because it benefits us now, but I'm sure that these will be benefits that are realized later on. And sometimes vendors can be slow to agree that, oh, yes, someone will be asking for this in 5 years. And so working in the open standards, I think, makes that go easier.
Yeah, it gives you a hand in the pot, allows you to stir the pot. I think I can recount my experience from SYCL, chairing SYCL, is that you guys contributed the feature that had to do with not wanting to create a template name for a kernel, which used to be in SYCL. Now you don't have to do that, right? That's
Right.
pretty non-standard stuff for code, so you don't want to go through the hassle of converting all your code to adding that template name, right, for every kernel.
Right.
And the other one was, I think, correct me if this did not come from you, I think it did, was the fact that you want to be friendlier towards pointer-based computing. The fact that
Yes.
unified shared memory is now in SYCL 2020 means that you can now adapt it to more pointer-based code, even though you are moving into more object-oriented code, but you still have a lot of code that's probably pointer-based. Is that right?
Right. For better or worse, pointers are still a widely used thing. And so the unified shared memory is a big advantage for our users.
Yeah. And now both those features are in SYCL 2020 because of your participation. And that's going to benefit, I think, a lot of other national labs, a lot of other adopters as well, too, who are basically in the same situation. So thank you. Are there other standards you guys are looking at in the future? Things like RISC-V or other ones? Have you guys looked at any of those other standards that you are?
Yeah,
Yeah,
we're always exploring future things, future architectures, future programming models. We have a test lab where we install like one or two of something, and then we test it or evaluate it, experiment with it. So that's always an ongoing, continuous process. And like I said, since we have a competitive procurement, we don't know what might be submitted, and so we're always trying to stay abreast of what technologies are out there.
Of course. Do you also watch closely what the Europeans and the Chinese national labs are doing? Because they seem to be heading towards some, slightly different directions. U.S. national labs tends to go towards vendors, as you guys said, commodity, off-the-shelf, direct COTS stuff. But it seems that the Europeans are heading towards specifically heading towards more homegrown, like what they think is homegrown. So maybe ARM-based with RISC-V. Same with the Japanese national labs, and the Chinese might be developing their own chips and things like that. Do you keep track of those directions and see where they're going?
Yeah, we're always, we try to collaborate with as many people as possible. So for wherever they are, we're always looking at what they're doing and trying to learn from what they have.
Right. Okay.
I think you can always view the top 500 as a competition, but at the same time, it's a friendly competition, right? People
Yes.
are always trying to just build better machines that can do more work. So trying to learn from each other.
All right. Well, this is great. I'm glad you mentioned top 500, and we'll close with that question. Do you feel comfortable with a prediction with Supercomputing 21 coming up? Well, two prediction is, are we actually going to be physically be there? And the second question is, who's going to be at the top 500? Okay. Yeah, go ahead. And then I'll give you
I
what
can firmly say that I probably won't be there in person. And as far as the top 500 list, I have no predictions what might happen. I'm hoping for something interesting.
Okay. Fair enough. I'll answer too, because I put it on you. So I don't know if, I don't think we're going to be physically be there. I mean, I probably will have to be there, but it will be it could be a hybrid. So we were virtual last year, and now maybe it'll be hybrid. And the top 500, I am very much hoping that Aurora will be in that list.
I hope so too.
I'm rooting for you. I'm rooting for you guys.
Thank you.
Well, thank you very much. It's been a great chat. We've gone over a lot of stuff, talking about the open standards, talking about ALCF, talking about the scientists and the workload, and ranging into programming models, why SQL, and why we're also continuing with OpenMP, and things like the metrics and efficiency and data issues. And so it's been, as well as one API, what experience you guys have had. So it's been a wonderful collection of experience. I want to say thank you very much to the wider internet audience out there, but also thank you specifically to Kevin Hom for this wonderful hour. Any last words, Kevin, would you like to say to the?
Yeah, thanks, Michael. Thanks for having me here, and I enjoyed the discussion.
Thank you.